So we know we wish to put in a tied expansion joint on the riser run of pipe to solve these large load problems on our pump nozzle. Before we select an expansion joint from the catalog, we have to know how much demand we have in terms of deflection of that point. Now, what I would suggest you do is determine how much this nozzle right there is node 10. That's just getting a close up right down here. 10 to 20 is the flange, and then 20 to 30 was the straight pipe off of the top discharge nozzle of that pump. We have to know how much this nozzle wishes to move laterally if it was able to move freely. Now, I guess you could just remove the anchor connection at node 10 and let it float, but then you got a problem with the dead weight versus the thermal components, and also that pump itself has some thermal growth on it. So what I suggest you do is just come on the other end of the flange, and we see here that I've changed. It used to be 10 to 20 was the flange, 20 to 30 was the straight pipe. So we have a node pair here that are just basically the same point in space. They're welded together. I'm suggesting that you change it from 10 to 20 and change the exiting node to 21 to 30. So now these are broken. These are two separate systems basically. And then add restraints between 20 and 21 where the expansion joint would usually not allow any free motion. Well, the tie rods will not allow the expansion joint to move up and down with respect to the other end, so I put a restraint in the Y direction between 20 and 21. That's modeling the tie rods. Also, the two plates on either end, because of the parallelogram that I developed with the tie rods and the flanges, I cannot rotate about the X or Z axes between 20 and 21. So these three restraints are pretty much active all the time, even with the tied expansion joint. But the other three directions, the two lateral terms, X and Z, and the third rotation term, rotation about the Y axis, are free in this sort of situation. Now, you're not supposed to put torque on an expansion joint, so we'll talk about it a little later. But right now, this sort of model is an easy change to make to an existing model. And when you run this analysis, you can use the results then to